Okay, so we have some grid of numbers, and we want to find what is this less or minimum numbers of operations to convert these numbers to the same value with a given number x, and we can do it plus x or minus x. So we're translating it to some same values matrix. So the matrix itself is irrelevant. I don't know why it is matrix. The problem is about the list of numbers. Now the solution is, so we have to consider what can we do, what does it mean to do plus x or minus x for particular number. Like if we have number 1 and our x equal 2, what we can do with this? We can do number 3, number 5, number 7, and so on. And if we have number like 2, then we can make number 4, 6, 8, and so on. And it's obvious that if we have numbers number sequence of 1, 3, 5, 7, it didn't match with numbers of 2, 4, 6, 8. It didn't match at all, and that tells you something. There is a hidden property about these sequence numbers. And what it is, how can we be sure that some numbers are matching and some never match? So let's look at different numbers like 1, 7. This is our numbers, and the x, for example, equal 6. That means if we do plus 6 here, we get an 7, and it matches. It also means if we do minus 6 here, it became 1. It matches with 1. So, but how can we find this property programmatically? Imagine we have not like 7, then it would be like 13. So imagine we have a big number, so we can't just in one operation say that it matches some number 7. How can we check that these numbers are matching? And you have to observe what are these properties, and eventually you will see that if you do like 1 modular operation 6, like a reminder, it is 1, and 7 modular operation 6, it is also 1. So it's kind of tell you something. It tell you that there is a sequence of numbers that starts with 1, and when you add in 6 plus 6 plus 6 plus 6 plus 6, and that means your sequence of numbers is like 7, 13, so it is 12, 27. So, and if you do model operation 6, each of them, it always gives you just one single reminder. So this is how we can detect that all our values in grid can should be checked by modular operation x, and then it would be the starting point of sequence. Now, if you have starting point of sequence, it's not the it's a good start for our reasoning, but it's not yet the final solution. So imagine we have this list of numbers 1, 7, 13, 20, 27. But how can we find this? So it is 1, 7, 13, 20, 27. How can we find the baseline? Some baseline that would make the number of operations minimum of required number of operations. So we have to convert this to the number of operations. Number of operations from 0, from the first number. How can we do this? We doing this -1 minus starting point. Yep, became 0, 6, 12. What does this? This is not. What is this? So this is not correct. This should be 14, and this should be 21. Or oh no. So 7 plus 6, 13, plus 6 is 19, not 12. And then 20 plus 6, 25. So it became 18, 24. And so this is adjusted from starting position. So basically we did minus modular x operation for each of the value. After that you can do divide by x for each number, and this would be the number of operations, or operations count. So became 0 divided by 6, 1, 2, 3, and 4. So this is a list of numbers of operations. I already sorted them, but they can be shuffled in the grid. And this is a part 2 of this problem. We have to find the baseline number of operations that would give us the shortest sum number of operations to make it to the base. For example, we can choose the base of this number, like 2 in the middle, and that means we have to do plus 1 to the left, plus 2 from 0, minus 1 from 3, minus 2 from 4, and they of course absolute number of operations, and this 3 to the left and 3 to the right, it is a total 6 operations. Now if you know math, that means you can say that I just use median, but that's only if you know, and by knowing I mean you can prove it. However, if you don't know, you are like me, so, and I don't know why it is medium, so you just can search it. 0, 1, 2, 3, 4. Then you move the pointer to the right. You know the sum of all these values. It's 1 plus 2, 3, 6, 10. So 10 to the right. You should, if your baseline is 0, you have to do 10 operations to the right. Then you move I to the next position, and you make some shifting in a O of one shifting of our right suffix sum and left suffix sum. So from the right, so our new base is 1. That means we can do -1 for each of this value. So that means, and our base increased from 0 to 1. That means we have 0 minus 1 increase times how many we have in our base, like 1, 2, 3 numbers, maybe like this, or maybe 2 numbers, I don't know. So it was 4 numbers, but we shifted to the right. So let's say it would be 4 numbers. And that means 10 minus 4, it became 6 to the right. Let's check if our logic is correct. So if we move in baseline to this 1, that means 2 minus 1 is 1, 3 minus 1 is 2, and 4 minus 1 is 3. The sum is 6. And to the left we have to do kind of the same, 1 minus 0 leveling, and how many values we have to the left times 1. This is our left sum. And our total number of operations is left plus right. Basically 1 plus 6. And this is for position of 1. And then for position of 2, it would be the same logic, and you can check it, but the total would be left equal 3 and right equal 3, and the total number would be 6, and this would be optimal. So we can kind of scanning these numbers as they should be sorted for it to work, and we looking for the left and the right sum of operations. Now let's look at the code. So I solved it in 53 minutes. It took me so long because I didn't know about the median, and I have to do my mathematical calculations. I also have slow brain in the morning, and this is what it took me to see these properties. So first I have to deduce by myself how to use this baseline. So the modulo trick wasn't very obvious at first, but it kind of came to my mind. And after that I had to invent the algorithm for the median value instead of using just median operation. Now I previously solved this problem almost 365 days ago, and at that time, so I had this previous solution, I spent 30 minutes, 35 minutes, but I used the hints, and after 1 year of my training I was able to solve it in 50 minutes without hint. So it's kind of more endurance, but I didn't add to my intelligence very much, so that's kind of taking it slower and sitting longer, but So I basically trained my endurance and not the intelligence, because if would I trained intelligence, I would be just solid with median from the start. Now let's look at the golf solutions. So this is a Kotlin one. They basically trick reduce help to flatten this grid. So this is a nice neat trick, reduce, if you want this kind of tricks. And sort it, and then just sum inline check for the same property of modular, and then use the middle operation. This middle is what I call median. Now let's look at the Rust. It's kind of has this concat number that would do this flattening of the grid, and this is pretty trivial and pretty verbose. That's it for today.